Hello everyone. This is an example of dependent source circuit where we will find Thevenin equivalent at terminal AB. For getting the Thevenin equivalent, we will calculate VTH and RTH. VTH is basically open circuit terminal voltage of AB terminal, and for calculating the RTH, we will see two methods where we will calculate RTH in each method, so which will be discussed in the coming discussion. This is our Thevenin equivalent where VTH in series with resistance RTH for terminal AB, where our load resistance is 10 ohm. So first we see the calculation of VTH, then see the calculation of RTH. For VTH calculation, this is our network where we will remove the load 10 ohm and this open circuit terminal voltage is defined as VTH. As you see this network here, I0 will become 0. It means 2I0 will also become 0. So in this network there is only a 5 ampere current source response. If you see this response, then this 2 ohm current will also become 0 because it has open path, and this 5 ampere current will circulate in this 5 ohm resistor. So for calculation of VTH, if you see, it is the directly calculated by voltage across this 5 ohm resistance, and the current according to current direction, the polarity of this resistance and VTH will be same. So our VTH is 5 into 5, that is I into R, that is 25 volt. So this is our calculation for VTH. Now let's see the RTH calculations. For RTH calculation, all the independent sources will be replaced by their internal resistances and load terminal become open. For the dependent source circuit solutions, we will calculate RTH by two different methods. So let's see. First we see the equivalent for RTH, then we will see both methods. This is our equivalent for RTH where independent source, that is 5 ampere current source, replaced by their internal resistance, that is infinity open path, and load will be removed, and this terminal resistance is defined as RTH. So let's see the method 1. For method 1, the concept is that RTH is basically voltage drop across this terminal divided by current flowing through that terminal. So for that calculation, we will connect a 1 ampere current source and assume the voltage drop across this 1 ampere current source is V. Then we will see the response in this particular network, and that response will be calculated as RTH. That RTH is V divided by I, that is 1 ampere. You can calculate this by other means. You can say V voltage source connecting across this terminal, and you can flow 1 ampere current source through this terminal, and then we can calculate the RTH, that is V by 1 ampere. Both the methods you can use. Either use a current source 1 ampere which is having voltage of V across its terminal, or you can assume a V volt voltage source which supply a 1 ampere current at terminal AB, and the calculation of RTH is V by 1. This is the concept for calculation of RTH. So let's see the calculation. This is our equivalent. Here we connect 1 ampere current source and assume V volt across this current source. So this I0 will be changed. So here we assume I naught dash, and according to this our dependent source value is 2 I naught dash. So let's see the circuit. Here you can assume this current is I1 and this is I naught dash, and this I naught dash is equal to minus 1 ampere according to current source direction. And if you assume this is node N and our circuit points are A, B, C, D. Now apply KCL at node N, and this is I1 is equal to 2 I naught dash plus I naught dash, that is 3 I naught dash is equals to minus 1. It means I1 is equal to minus 3 ampere. And let's see the calculation of for V and apply KVL. In path A, B, C, G, A. And if you see the current direction, according to current direction, 2 ohm resistor polarity is this and 5 ohm resistance polarity is like this. And then apply KVL A to B, minus V, then minus 5 I1 minus 2 I naught dash is equal to 0. So here we get V is equals to minus 5 I1 minus 2 I naught dash. I1 is equals to minus 3, put the value, that is 15, and I naught dash is minus 1, that is plus 2. So here the calculated value of V is 17. Now let's see the RTH. RTH is basically V by 1, that is 17 ohm. So this is our calculation for RTH by method 1. This is our method 2, where RTH is defined as open circuit voltage divided by short circuit current. Open circuit voltage is basically a Thevenin's voltage as you calculated in circuit, and the short circuit current is basically if you remove the load and the load terminal becomes short circuited, and this current is defined as short circuit current. According to this current value, our circuit parameters will be like this. This is loop current become I short circuit and dependent source current become 2 times I short circuit. Basically, this methods uh, uh, defined by using two theorems, that is Norton's theorem and Thevenin's theorem. If you analyze the equivalent of these two theorems, then by using source transformation you can see the formula of RTH, that is open circuit voltage divided by short circuit current. So this is another method. Let's see the solution. For the solution of this network, we will analyze this network and calculate short circuit current. So for the analysis, we can apply nodal analysis in this particular network. So for the nodal analysis, we will assume reference node. So here we use nodal analysis for calculation of ISC, and here, and this is our node voltage V, and this current is 5 ampere, and here you can assume this current I and apply KCL at node. So the KCL at node, there is only single node. So this KCL is 5 is incoming current and all the currents are outgoing, that is I plus 2ISC plus ISC. So here you can calculate I. That I is you are seeing this is V minus 0 divided by 5 ohm. So the value of I is V minus 0 divided by 5, and if you see the value of I short circuit current, that is V minus 0 divided by 2 ohm. So this is our values, V minus 0 divided by 2. Put all these values. 5 is equals to I is V by 5 plus you can say 3 ISC, so 3 into V by 2. So let's calculate the value of V. 5 2s are 10. This is 2V plus 15V is equals to 5. That is 17V divided by 10. So here we get the value of V, that is 50 divided by 17. Now calculate I short circuit. This I short circuit is equal to V by 2, that is 50 divided by 17, that is 25 by 17. So now calculate RTH. The RTH is open circuit voltage divided by short circuit current. As you calculate our VTH is 25 volt. So the RTH is VTH divided by short circuit current, that is 25 divided by 25 by 17. So here we get the value of RTH is 17 ohm. So this is the concept of method 2. Hope you understand the concept of calculation of RTH in dependent source circuit. The Thevenin equivalent at terminal AB is like this: VTH in series with RTH. Our calculated VTH is 25 volt and RTH is 17 ohm. Thank you for watching the concept. Please like and subscribe my channel.